Alright, so the next example, I'm going to kind of again go through everything. Increasing, decreasing, extrema, inflection points for an exponential function. Alright, so here I've got an exponential function. Actually, this is a fairly complex one because there's the x out front. So there's actually two functions. There's the x function times the e function, which is raised to the negative 1/2 x squared. So there's actually three functions here. I'm going to have to use two rules, product rule and chain rule. Alright, so first, I'm going to do the first derivative and determine critical values, increase, decrease, and those things, and then I'll get to the second derivative after that. So I'm going to do the first derivative. So again, I'm going to find any criticals first. Critical values, which means I need to find my first derivative, determine if it's 0 or does not exist. This function exists everywhere, and so will its derivative. Alright, so there are two functions. There's the x and the e term, so I have to use the product rule. The first function is x, so it's first, times the derivative of the second, which is the e term raised to the square, so I've got to use the chain rule there, so it's e negative 0.5 x squared. Not done yet, though. Derivative of the inside. I take it my negative 2 times my negative 1/2. I'm going to get negative x plus the e term. So my second. Alright, there's first. Derivative of the second. Second. Derivative of the first, which the first function is just x, so its derivative is 1. So there's my derivative, but not simplified yet. And I do want to simplify because in order to solve for the 0, and you could graph it and find a 0, and it's fine if you do that. But I'm going to show you the algebraic method. So if you get to this point, you're not sure where to go from there, you can always solve it graphically like I showed in my previous examples. But I'm going to go through the algebraic method because, again, it's also good. It's actually, I think, quicker to solve it algebraically. Remember, the rule of thumb is always factor out the e. Whenever you have an e term, there should always be 1 in both expressions, and there is. And so my rule of thumb is always pull the e term out. So e to the negative 1/2 x squared times, well, what's left over in the first term? I had an x and a negative x. So x times negative x is giving me a negative x squared. In the second term, I just have the 1 left over. And I do have a 1 left over. Alright, so it's still there. So I've got the e term times the polynomial x squared minus 1. Now I'm ready to set it equal to 0. And remember, the e term is never 0. So the only place I can get a 0 is out of the polynomial part, which is why we like to factor it this way. And so my negative x squared plus 1 is the only place I can get a 0. And so I solve that. I'm going to add the x squared to the other side to get a positive x squared. Use the square root property. Remember, when I use the square root property, I get 2. And so my critical values are at x equals positive 1 and at x equals negative 1. So those are my criticals. All right, my critical values, not my critical points. To find my critical points, I would take 1, plug it into my original expression. I take negative 1, plug it into my original expression. So remember, the original expression was this xe to the negative 1/2 x squared. So it's going to be, I'm going to get the same thing for both positive 1 and negative. Oh no, I'm going to get a positive and a negative. Alright, so I'm going to come back to that, and I'll find those after I do my testing. Well, maybe I'll go ahead and find them now. Alright, so f of x was xe to the negative 0.5 x squared. Plug 1 in. So when I plug positive 1 in, I get 0.60. So I'm going to round 2 decimal places. 0.61. When I plug negative 1, I'm going to get the exact same thing, but the negative. Because I've got the negative 1 out front. .-61 if you type negative. Alright, so there are my critical points. Now to determine the increase, decrease, and whether those critical points are maximums or minimums. Alright, now I'm going to use my test line. Remember, it represents my domain. So my domain for my original function was infinity to negative infinity. I mark off my stopping point, right? This is where we stopped. Right? The function was neither increasing or decreasing. So it has horizontal asymptotes at those moments. So it stops at negative 1 and it stops at positive 1. I take my derivative and I test points and see what my original function is doing. And so I've lost my derivative. So let me go back up here and get it. So I'm going to write it down here so I have it. Alright, so my derivative function was e to the negative 1/2 x squared times negative x squared plus 1. My negative. Same thing, this is always positive. So the e term is always, remember, e term's never negative and it's always positive. So really, I just have to look here. When I plug my test points in, so this is going to kind of work smarter, not harder kind of thing. I just have to figure out at my test points, is it positive? Increasing. Is it negative? Decreasing. E is always positive, so I can sort of ignore the e term. It's always going to be a positive number. And so I just look at the polynomial part. So when I look at this, this is what I'm going to look at when I test. I'm going to see if it's positive or negative. Alright, so my test points. So I can pick anything I want, so I like my negative 5. 0 is always a good one to pick, right? I've got 0 between negative 1 and 1. And then I like to be consistent, because a lot of times there's symmetry. So the negative and the positive will give me out similar answers, and that's going to be true in this case. And so when I take my negative 5, plug it into my derivative, my 0, plug it in my derivative, and my 5, plug it in. And again, I'm actually just going to plug it into this piece. I'm going to kind of do mental math. When I take negative 5 and plug it into negative x squared, well, I'm going to get negative 25, right? 25 plus a negative 1. And so that's going to come out negative 24. And so I know that's 0. This is negative, which means my function's moving down, right? Decreasing. Then it stopped, right? At the negative 1, the critical moment, horizontal tangent, stopped. Now when I plug 0 in, what's it doing? So again, I'm only looking at the x squared plus 1 because the e is always positive. When I plug 0 in, well, the negative part will 0 out, and I'm left with a positive 1. So this comes out positive, which means it did switch directions because my derivative is positive, my slopes are positive, my function has to be moving up, increasing. All right, then at 1 it stopped again, and then switches directions because the same thing's going to happen at positive 5 as it did at negative 5, right? I'm going to get a negative 25 plus 1 gives me a negative 24, and so it did switch directions. And so my stopping points, which are these points up here, are my relative extrema. And so I'm going to write my answer here. So I'm actually going to erase my derivative now that I'm done with it and write my answer over here. Okay, so, and again, I use the number line because I actually think its picture kind of gives away the shape. At negative 1, it moved down, stopped, then move up, which makes this a minimum, right? And so my negative 1 is a relative minimum. At positive 1, I moved up, stopped, and moved down, and so that means that shape gives me out a maximum. And so the positive 1 is a relative max. Alright, so there's my max and min parts, and now we're writing out increase and decrease. Alright, so f of x is increasing where my arrows are moving up, so only over the interval negative 1 to 1. F of x is decreasing everywhere else, meaning at the ends. Over the tail, negative infinity to negative 1, right, moving down. Also from 1 to infinity, right, those are the places decreasing. Now we'll graph it and see that it reflects that. Alright, so remember the graph is sort of the checks up, and since I've got my graph working here, I'm actually going to pop it up. I already have it in my calculator. Alright, so I've already typed it in carefully, so make sure you're careful. X times e raised to, and make sure, I didn't put parentheses around it, but I probably should have. But you can see that the negative 1/2 x squared is all up here in the exponent. And if you'll remember, my max and mins were 0.61, negative 0.61. And so I adjusted my window. I go here to hit my window key. And since I knew my max and mins are real small, I could probably have gone smaller than this, but I left my 10 and my negative 10 for my standard window. But I made my y minimum a negative 2, my y maximum a positive 2, because I know my min and max are very small. Alright, and then I'm going to go ahead and hit graph, and it'll pop up the graph. And so there's the graph of the function. And then I can make sure that I did find the right point. So if you will go in, you hit second trace, select value, type in negative 1, enter, and there's my minimum, negative 0.606, which I rounded to negative 6.1. My maximum should be up here, and again, I can do the same thing, second trace, value at 1, and it is. 1 is at 0.6065, which I round to 0.601. And so now go graph it on my sheet of paper. Alright, so my graph checks everything. So my graph is sort of my check step that I did the calculus right. Alright, so I'm going to just simply graph it here. So, came down, crossed, and so it has this shape, so it comes down, up, down, up. Alright, this was the 1.61 if I round two decimal places. This is the -1, -0.61. This is a minimum. This is a maximum. It is, if I go and check my answers, it is from negative infinity to this moment, -1, my function's moving down. Then from -1 to +1, my function's moving up. And then from 1 to infinity, my function's moving down again. So it does follow the path. And it did stop at those two moments, right? My critical values were at stopping points where I have horizontal tangent. And so it does check that what I've got done here is correct. All right, we'll stop there. We'll pick up the next one, which is a root example, which means I'm probably going to have corners in that case in my next one, my next video.